Hello everyone. We are in the sixth module of machine learning and data science course, and unlike last week, we are going to be looking at two different models this time. Not two variations of the same model, but exactly two different models. One is k nearest neighbor, and another one is knife Bayes model. Okay, sorry. So, so the first model, k nearest neighbor, is actually used both for classification and regression tasks, and the second model, knife Bayes, is basically a classifier. So it's a dominant use or very primary use, or you can say that quintessential use is in spam filtering. So we'll see how that works and how that is implemented. So one of the model, k nearest neighbor, will look at mathematics, intuition, everything. So k nearest neighbor basically is a graphical model as per explanation. So there's not much mathematical concepts that would be too hard for one to understand. On the other hand, knife Bayes requires you to have elementary statistic knowledge. But even if you don't have that, we are going to be discussing fairly enough so that you get quite prominent with knife Bayes model as well, knife Bayes classifier as well. So it requires a little bit of math, more than k nearest neighbor, of course. So that is the case. And another thing is that we'll be implementing k nearest neighbor model in code, and we'll see how the implementation work. Actually, I've already implemented it, but I'll walk you through the entire code and you'll see how it works. And it's a very naive, very naive implementation per se, pun intended. And for knife Bayes, we are not actually going to be implementing in code. We'll just take a look at the implementation. Uh, you can say a dry run of some implementation, and we'll see how it works with spam filtering, and we'll get the idea. So let's directly jump into the first model, k nearest neighbor. And yeah, before going into the model, both or any of these models, why did I choose to keep both these models in one module? And even though they are not very related, they are, in my consideration, two of the very uh, least time consuming and very simplistic models to in a way, especially in terms of understanding these models. So yeah, these models will hardly take 15 minutes to explain, and they're not very hard to grasp, especially k nearest neighbor, and not even that hard to implement. So yeah, let's directly jump into the explanation. So let's start with k nearest neighbor now. So for this model, let us assume that we have been given a data set. So this is our data set, and we have, for now, let's say that we have two classes for this data set to be predicted. So we have y, and y can have a value of 0, 1, 0, 0, let's say something like this, and it goes on, right? So we have a data set and it can have two classes. So let's say that class 0 is represented with a O and class 1 is represented with an X. So when we go ahead and given these points, let's say since we can only imagine a plane in 2 dimensions or 3 dimensions at most, we'll be just taking a look at 2 dimensional data, but it also extends for 3 dimensional or 4 dimensional or n-dimensional data as well, right? So for now, let's just take a look at 2 dimensional data. So let's just say that we have an xi or x1 and we have x2 for this data, and so till xn and something like that. So let's just consider that there are two input variables, x1 and x2. So let's just say this axis represents x1 and this axis represents x2. So for each of the values of x1 and x2, we plot the point accordingly. So for example, if the coordinates of x1 and x2, these coordinate, the first coordinate gives you a 1, then at that point, so let's say that this point is somewhere around here, so we'll point uh, an x here, right? Similarly, when we go ahead and plot all these points, we'll have something like this. So we'll have a good number of x's and we'll have a good number of o's, right? So some will be here and there, so let's just say something like this, right? So as you can see right now, using just a linear model and trying to draw a linear line that divides these two isn't actually going to help a lot, because there will be some outliers, and there will be some values that will cross the boundary. So what we'll do, we'll understand how nearest neighbor works in this scenario. So what nearest neighbor says is, or k nearest neighbor says is that we choose a value, let's call that value k. So for example, let's say that we select the value of k as k naught, right? And what we do is that for a given value of x1 and x2, for example, this was our train set, so let's call this train, and this another smaller set is our test set, right? So in the test set we have x1 and x2 as well, and we have y as well. For a given value of x1 and x2, let's see where that point lies on the map. So we don't know what the value of y is right now, whether it is x or whether it is o, or it's 0 or 1, we don't know yet. So for example, if that point lies here, just by looking at that point, what can you tell me? Well, you might say that it belongs to the category 0 because it's closer to 0, or you might say that it belongs to a category x because it's closer to x. But how we are going to determine it? So in this model, what we are going to do is we are going to take the number k here, and what we are going to do is we are going to find the k number of nearest neighbors to that point. So for example, if the value of k is equal to 5, we'll take the 5 nearest neighbors to the point that we are looking to find the to find the class for. So here's the point. So 5 nearest neighbor to this point is this one, 1, 2, 3, and I'll say this as well, and probably this one, right? So we take these 5 points. Let me draw a dotted line around this. Let me just change the color of pen so it will be a little bit clear. So let's draw a dotted line. Right? So around this point, we have this, we have this, we have this. So these are the 5 nearest neighbor. Let me count. Are they 5? Yeah, 1, 2, 3, 4, and 5. They're not 5. Okay, yeah, I missed this as well. So this as well. So now what we'll do is we'll find the distances. So how are we actually deciding which of these all these points, which of all these points are actually the closest to the target point, our target point being this, right? So which all of these are actually closest? So for that we have two methods of finding the distance. One of the method is known as Euclidean distance, and another method is known as Manhattan distance, right? So we have Euclidean and Manhattan distance. So what is the difference between Euclidean and Manhattan distance? So for example, for a given pair of points, Euclidean distance just says that if the coordinate is x1, y1, and the coordinate is x2 and y2. So for the given points, directly just finding the distance using Euclidean's method will be x2 minus x1's whole square sum y2 minus y1 whole square, right? So this is how Euclidean distance works. On the other hand, let me just get rid of all this. So on the other hand, what we do is for two given points, we find the perpendicular for the set of points. So for example, if the perpendicular is something like this, then this distance between these 2 points is actually equivalent to sum of this distance, sum of this distance squared and under root. So for example, if this distance is a and this distance is b, this will become a square plus b square. So reminds you of something? Pythagoras theorem. Yeah, so this is actually the Pythagoras theorem that we have already studied in class 8 9 somewhere around, sorry, not even that, after, so maybe in class 6th or something, right? So that's fairly easy. So let's just say that we are using Euclidean distance for this given problem. What we'll do is we'll find the distance between this point and every other point on the map or on the graph, right? And from that we'll see which 5 points are actually closest to it. So here we found that by just looking, we found that these 5 points are actually the closest to the target point. So when given an actual data, what we'll do, we'll just take the distance between every point, then we'll sort it from lowest to highest, and then the 5 lowest point or the 5 lowest distances will give the points. So now when we look at this data, what we see that is 3 of the points, this one and this one, belongs to class 0, and 2 of the point, this one and this one, belongs to class 1. So for the target point, we can easily say that the target point belongs to class 0 because 5 nearest point to that class, or sorry, the target point are actually belonging to class 0. If it had happened that more number of closest points would actually belong to the other class, class 1, we would say that the target point belongs to the other class, that is class 1. So one of the important things to note here is that the value of k here is chosen as an odd value. Why is that? Because if it's an even value, there's a problem that can occur, that is there can be a tie between the number of points closest to the given target point can be of either class. So for example, if it had been 4, then 4 of the points would have been just these 4 points, and 2 of them would have been class 1 and 2 of them would have been class 0. So in this way it would have become difficult for us to come to a conclusion to which class it belongs. So now another thing is that if the value of y, if it's a regression problem, this was very easy one for a classification problem, but what if it was a regression problem? So in that, let's just go ahead and see how this would work for regression problem. So when it's a regression problem, we don't have different classes in our data set. Rather, what we have is that for, let's say, we have an input feature x1 to x3, and for that we have a value of value y in the data set, and value is something like 0.5 or something like 0.8 and all these values, right? So for each of these values or each of these entities, what we'll do is we'll look at the value of x1 to x3, and what we'll do is we'll plot these points on the graph. So now there are no two classes, there's just one class, and what we'll do is we'll just take these points and plot them wherever possible on the graph. So let's just say it's a three-dimensional data, or means there are 3 input features. So this is the plotting. Now what we do is when given a new set of values for x1, x2 and x3, so let's just say whatever values are given, we have to find the value of y, which is a question mark right now. So for these values, what we'll do, we'll point the value on the graph given the value x1, x2 and x3. So let's just say it lies somewhere here on the graph. So this is the target variable or the target point. So for the given target point, what we'll do, again we have the value of k as 5. We'll find out the 5 nearest points to this target point, and I can visually assume that these 5 points are the closest. Again, works both for Manhattan and Euclidean distance. Now given these 5 points, what I'll do is I'll find the average of the values that these 5 points have for y. So whatever value of y these 5 points have associated with them, I'll just take those 5 values. Let's just say yn plus yk, or no, let's just say y something, whatever, y something to y something, these 5 points, then I'll divide it by 5. Whatever value I'll get is my y new or y predicted, right? So this is how it works for a regression problem. So I don't think there's much to be discussed when it comes to k nearest neighbor. One important thing, or one hyperparameter that we have to decide on manually, is the value of k. So how do you actually get to a definite value of k? You don't. What you do is you keep on experimenting with different values of k. Whatever works for your data set, you go ahead with that. It may happen so that with time the value of k needs to be changed, right? Whenever new data comes in and you keep on appending, when this uh, test data comes in, you then find the value for this test data, then you append it to your training data as well, and at some other point when new data comes in, you keep on going appending it to your training data. And at later stages what may happen is that you might have to change the value of k from 5 to 3 or maybe even 7 or whatever. But keep in mind that it should be an odd number, not an even number, because again, the reasons I've already explained is that the even number may result in a tie between different classes and everything. So yeah, but yeah, for regression problem, I don't think there's any necessity for keeping the value of k as odd specifically. But yeah, why not? You can keep on experimenting and find out what works for your model or for your data. So now let's just jump directly into the code and take a look how the code is working.